So hello everyone, thanks for joining us for the fourth activity of the second international webinar series, Frontiers in Weed Science. We thank all the institutions that are part of it, especially the Brazilian Weed Science Society for providing Zoom access. We especially thank Dr. Harry Strek that accepted the invitation to share with us his experience now live and later on the recorded YouTube channel. So Harry Strek grew up in North Carolina and worked on farms during summer breaks. After finishing high school, he studied botany and chemistry at the University of North Carolina at Chapel Hill. He then earned his master's in 1980 and PhD 1984 degrees in weed science from the Department of Crop Science at North Carolina State University. Harry started his professional career with DuPont Crop Protection in 1984, working on soil persistence and recropping issues with sulfonylurea herbicides, overseas assignment to France, Russia, Germany, and lastly, in the environmental faith group back in US. In 2008, he left DuPont and the US and began working at for Bayer Crop Science in Frankfurt as head of profiling and market support, weed control research. Currently, he is scientific director with Resistant in Frankfurt at Bayer Weeds Research Competence Center. So really appreciate Dr. Harry to be here with us, especially this late because you are the second speaker that we have that's from Germany. So it's currently midnight where he is right now. So appreciate so much your effort to be here with us. And he'll be talking about weed management as a way to integrate weed management as a way to manage resistance. Thank you so much.
Thank you very much, Ed and Alvo, and also to Luis for inviting me. And I'm really happy to do this, even though it is pretty late, but I don't have it as bad as the speaker following me, so I guess I can't complain. So I'm going to talk a little bit about integrated weed management as the way to manage resistance. I'll start with a little bit of information on the current status of global resistance and industry research in weed control and finding new compounds, new herbicides. Then I'm going to go to an explanation of why integrated weed management, or IWM, is necessary. Then how IWM can impact weed management in a positive way. And then the hardest part, I guess, is how can we convince farmers to adopt IWM before they really have an issue? That's really the hardest part of my job. And then some final thoughts. So this is a map showing a count of confirmed resistant weeds across the globe. And it is a global issue. And the data comes from what's so-called the HEAT database, and it's the International Herbicide Resistant Weed Database that's sponsored by HRAC. And it's a count of the resistant species by country. Number one, of course, now, it used to be America or US, it's Europe. And I include Russia and Turkey in Europe for this presentation because parts of the countries are in Europe. And they lead with 86. Number two is the USA. And then number three is Australia. Number four is Canada with 38. And then we have Japan with 33. And then Brazil and China are tied for 5 and 6. And then little Israel has 24. Now, does that mean that Israel is just has a resistant weed across the entire country and in every corner? Not necessarily. I think Israel probably has the most active weed scientists in the entire planet, and so that's why they have a lot of cases that they've recorded. They also import a lot of seeds, and it seems that they every few years they get a new resistant weed species because it's come in on some batch of seed. But and then we have other countries, that are in gray, and that does not necessarily mean that they don't have resistant weeds. It just means that there's nobody there to describe it, or they haven't validated it yet. So that's the reason for that. To date, 63 different weed species have been developing resistance to a herbicide or multiple herbicides in 95 crops and across 71 countries. And that's of just yesterday or day before yesterday. Another aspect of this is looking at this from the selected modes of action, or MoAs, as I will refer to it in this presentation. And you can see that it's a continuously growing problem. And I've put the bottom scale in terms of the year after market introduction. So, and of course, glyphosate is the year after 1990, or starting 1996, the year after Roundup Ready introduction into the market. And you can see that there are some lines that go up very fast. That's for the ALS or group 2s. And this is glyphosate, as I mentioned before. This line here is for the PS2 serine 264 binders, or group 5. Then we have here the ACCase compounds, or group 1s. And then we have here the auxins, which have gone over 70 years. I mean, the first one, of course, is 2,4-D. But then we have some ones that have just gotten started, like PPOs, and the very long chain fatty acids. They seem to be going very slow. Now, the ALS is probably one of the fastest ones because of, number one, there are so many compounds in this group, and it cuts across so many crops, and such a diverse group of chemistry, so that it's out there. And perhaps also that the frequency of mutations that confer resistance seems to be a little bit higher than for other compounds. But in all cases, newer chemistry or older chemistry, all of them are going up, of course, at different rates. So here's a look at the unique cases in Brazil. And a unique case, if you haven't looked at the database, is a combination of a weed species by a typical resistance that can be a single or multiple modes of action. So you can see here, I've divided this out between grasses and broadleaves, that they are climbing fairly closely to one another at a similar rate, where every few years, the newest unique case gets is on this graph also. And you can see more and more that you have multiple modes of action appearing, and which is called cross resistance. And so you have more and more the fact that weeds are appearing to accumulate resistances rather than trade them and drop one. It's a lot harder to get rid of a resistance than it is to acquire it. Let me move on to the industry. This graph here shows the number of active ingredients in 5-year increments launched since 1950, and shows that it has reached a plateau of about 30 active ingredients for a 5-year period between 1990 and 2000, and then there was a steady decline. And when we contrast this with the number of patents applications for herbicides across the globe, we can see that we had a high of about 250 per year. This is on the right axis. And we went down to a low of about 35 in 2007. And since then, It plateaued at around 50, but has recently started to go up. And I don't have the latest data for this year, but I anticipate that it will also be higher. And I think the number of active ingredients is going to turn around. So the industry has been finding new active ingredients, and it also has been finding new modes of action. So that drought, that 30-year drought, is coming to an end. But that doesn't mean that everything can go back to the old ways, and I'll tell you why. One of the reasons is that we've got a lot more different kind of resistance mechanisms. In the old days, we used to have just target site resistance, which is conferred by a target site mutation that changes the physical configuration of the binding pocket and makes it harder for the herbicide to bind, and therefore reduces the activity of the herbicide on that weed. But we've also fairly recently found that increased gene copy number is another mechanism, and we've had enzyme overexpression in a few cases that are responsible and are considered also target site resistance. Then in the non-target site resistance mechanisms, the most earliest one that we found was enhanced metabolism. And then we've also got reduced uptake, differential redistribution, sequestration into, say, something like a vacuole, delayed germination, which is a great way to avoid pre-emergent herbicides. And then a fairly recent one too is rapid necrosis, where, for example, an ambrosia species can drop its leaves within 24 hours after a glyphosate application. It can necrose and drop its leaves, taking a good bit of that glyphosate with it, and thus protect the apical meristems from accumulating too much and surviving. You know, it takes a deep breath and then just continues to grow, which is a unique resistance mechanism. So Mother Nature's always coming up with new ways to find resistance to herbicides. And, you know, these two are the most common: target site mutations, or TSR, and enhanced metabolism, or EMR, because they're two of the easiest ones to figure out and to do experimentally. And increased gene copy number is also not that difficult. But the other ones take quite a bit of work. Usually, you know, we can do these in our laboratories, but they're not routine. And generally speaking, investigations into resistance mechanisms have gone on. And then once we find something that is fairly major, we tend to stop and not do the full gamut of every single mechanism. Eventually, that will be probably easier to do when we have more genetic techniques that we can do much more routinely. But that's not where we are yet. There's also a number of cases of resistance through multiple mechanisms or multiple resistance, and to multiple modes of action across resistance that is growing increasingly. And it seems like once a weed has found a way to metabolize an herbicide or a couple of herbicides with similar structures, it doesn't take very long to crack the next herbicide that it's exposed to. So we seem to be training these weed populations to break the next chemistry that's used, if we use chemistry only. And that's one of the major reasons why we need IWM, or integrated weed management. So one other aspect that may be overlooked some is that some of these mechanisms may not contribute very much to the overall picture, but if you string them together, and each small or weak mechanisms can be added together, and the effect of addition might actually work into an exponential curve and actually make a very strongly resistant plant out of the accumulation of a lot of little things. Remember, Mother Nature has had a lot of practice in adapting in various ways and putting things together to make it resist make a plant resistant to an important stress and a major stress. So that's one aspect that we probably need to investigate more in the future. The other thing is that weed biology, including the dynamics of the weed seed bank, is often overlooked until there's a problem like resistance. And it's understandable because herbicide use was such an easy way to control weeds, and of course is the most economical, most convenient way to do it than the alternatives. And so in the recent past, the biology of weeds has kind of not been seemed very important to do much research on. A lot of the work on germination of seeds has been done 50, 60, even longer years ago. And only recently now, with the advent of green foods and biological ways of doing things, has ecology become more important. And this is an area where we as weed scientists need to work more with our biological colleagues working on biological control to work out some of the ecology of the weeds, because the objective is to disrupt the biological cycle of the target weed, like germination, weed growth, flowering, seed set, and seed rain, and then figure out which are the best intervention points for a particular species. And then, of course, disrupting several at the same time is a great way to make sure that your weed control measures, when you put them together in an integrated program, are working even better. And it's also helps to know the biology of the weed to more effectively add or allow the addition of non-chemical weed control measures. So when we look at weeds, and I've highlighted here a few weeds that are familiar to you in Brazil, and others that are more familiar elsewhere. But when you look at the seed production per plant and the maximum survival in the soil in years, we can see that we have quite a range in some of the species, and some of them have astronomical numbers, over 1 million seeds, and survival in the soil of up to 50 years. It's an incredible what resource the seed is. So it's important really to focus on the weed seed bank in weed control. And that's one of the things that really helps when you helps to understand why integrated weed management is so important. Weeds can produce a lot of seeds and do it over years. Now, when a seed hits the soil, it doesn't automatically go into the weed seed bank. There are predators who like the seed. I mean, it's a great source of food and energy for birds, for insects, for invertebrates, for fungi, and for small mammals. And so you lose a lot of seeds to predation of various kinds, and the rest goes into the soil seed bank. And what I like to do is I like to explain weed seed bank dynamics with kind of a theoretical model. And it's a really simple model, and I'll explain a little bit about it. So my model assumptions start with 1,000 seeds per 10 square meters in the seed bank. We assume that the plant or each weed will produce 200 seeds in a season. There's no seed removal from the field. That means none is transported away. And that 10% of the seeds survive and germinate, and 75% are lost through predation of the various means which I mentioned. 10% germinate and don't survive, and 5% don't germinate at all for some other reason. And there's no germination after year 1. These are all consistent with some of the values that I found in the literature, but of course they're very conservative. So what we have in effect is about 10% annual survival of seeds in this model, okay? Again, this is just a theoretical model. Now, a reality check with the ryegrass biology, or IWM in Portuguese, and the sourgrass, or the Capim amargoso, so lolium species, and the Digitaria solaris, show that, you know, these numbers that I'm using in the projections are very conservative. So let's just go through the math real quick. So we have 1,000 seeds in the seed bank, all germinate. If you did nothing at the end of the season with 200 seeds per plant, you would have 200,000 seeds, okay? Now, we're gonna add weed control. And in fact, we're gonna start with 80% weed control. So out of those 1,000 seeds, 200 weeds are surviving the herbicide, and times 200 seeds per plant equals, at the end of the season, 40,000 seeds that are produced. And then 10% survival at the beginning of the following season means that 4,000 seeds are germinate and producing a plant. So that's a 4x increase, 4-time increase in 1 year, okay? Now, I've done the math for you. So 100 remaining goes to 400, 1,600, 6,400, et cetera, and pretty soon it just blows up, all right? Now, what I've done for you is to do this on a graphic scale to make it a little bit easier to interpret. You don't have to look at the numbers. So we start with 80% weed control, and we can see that the weed seed bank is accumulating very rapidly to very astronomical numbers. Is 90% weed control enough to start decreasing the weed seed bank? What do you think? No, it's not. Not even, not even close, you know. Is 93% enough? No. 95% enough to start decreasing it? It looks better, but it's technically no, it's an even line. So in other words, at 95% control, you're just keeping the weed seed bank at what it is. 96% control, you start going down, 97% and 98%. So it takes a high level of weed control, even with these very conservative assumption, to keep the weed seed bank from accumulating. And even small increases in efficacy at these levels can have a big effect over time. And this is the important point, it's over time. So, question, does it change with the initial population if you reduce it to 10 weed seeds per 10 square meters? If you do the same thing, just run it through quickly, no, the trends don't change with initial population. However, some absolute values are reached sooner because you have less seeds in the beginning. Very logical. So does it change if you put the initial population to 10,000? No, it's the same thing. Again, the trends don't change, but the absolute values are reached later, actually. So I've taken this 80% weed control that you're familiar with, and now what I'm going to do is a little bit different thing. So we're going to assume that we have a resistance mutation frequency of 1 in a million plants. So then we get target site resistance. Now, I know that probability theory doesn't work this way, that you just accumulate a million plants and then you have a mutation, because it can happen anywhere in there. But let's say that on average, that is the case, and the odds are greater to get a mutation the more population, the denser the population is. So if we do that and we use the sum of a geometric progression to sum up everything, so in other words, we sum up all the seeds that were produced in this model, and I've done that for you, we can sum them up and we can see that somewhere between year 7 and year 8, we kind of cross that 1 million seed threshold, all right? So I've done that in a graph again. And what you can see is that at 80% weed control, it's 7.4 years. until we cross that 1 million seed threshold and we get resistance. Now, what happens if we go to 90% control? What does that look like? Okay, we can see that we've almost doubled the time that it takes to get that to that 1 million seeds. And that means that you effectively have increased that that lifetime of that herbicide, or doubled the life expectancy of that herbicide in that field. So increasing the level of weed control to 93% doubles that almost even further. And then, of course, with 95% weed control, it doesn't really matter. So high efficacy aids in slowing down resistance evolution because you just have less plants that can mutate. So you have to ask yourself, how much is an extended product life worth, especially when it takes decades to get rid of, we don't even know how long it takes to get rid of a mutation that confers resistance in a field that's already been shown mutations. And so it's worth a lot if you can keep resistance out of a field, but once you've got it in the field, you're basically stuck with managing it and the other resistances that that it seems to that populations eventually accumulate over time if you use chemical only, herbicide only solutions, and don't use practices like using mixtures and optimization of the chemical part of the weed control management program. So let me show one more aspect of this theoretical model, non-chemical seed suppression, and show that it can help. So you're familiar with this, 90% control. So now we're going to add 25% non-chemical seed suppression, like with a cover crop, let's say. And these are realistic values, 25%, 50%. Those are values that you can expect. There are values that I've seen that go as high as 70% suppression of weed seed formation. And again, this is about controlling the weed seed bank. So when we have 90% control and we add 25% non-chemical seed suppression, lo and behold, it does have an effect. When we add 90% control and 50% non-chemical seed suppression, look at that. It works like 95% weed control. So it's added an extra 5% weed control, went from 90 to 95, and that is significant. It's keeping the population at bay. And when we add a 1% control boost, now that boost is that if you have a dense population of weeds and you apply an herbicide, there's going to be a lot of shading or some dilution. Depends on if it's a pre or if it's a post, but in any event, herbicides work better when the population densities are lower. So suppression of 50% of the weed seed by a cover crop can lead to a 1% boost, and that extra 1% boost again can have a big effect. So again, even levels of seed suppression considered as unimpressive can have a big effect on slowing resistance evolution over time. Again, you're talking about over time. The yearly differences are not that impressive, but over time they are. And non-chemical seed suppression does another thing. It helps to reduce the selection pressure for herbicide resistance. So what can you do to help farmers manage resistance? Number one is you develop a strategy to attack weaknesses of the key weed or weeds, or we call them the target weeds. So if it's a winter annual or winter growth period versus a summer growth period, add a summer crop to the rotation. Okay, in some places, it's not really possible to, especially in more tropical areas like parts of Brazil, you don't really have a true winter and summer in terms of temperature, but it certainly does help maybe to switch the seasons around for the different crops, because you have different different herbicide portfolios that you use in the different crops, and also the biology of the crop. Weeds get used to the crops that are grown there. In fact, if you use a corn-soybean rotation, some work has shown that some crops that are particularly competitive in soybean will know that a corn season is following and wait till the soybean gets there and then germinate then. And there are so many different ways that weeds will figure out how to bring an advantage to their situation in a routine cropping system. And of course, monocultures, they can figure that one out very quickly. So if it's an annual or if it's, a perennial, then spot treatments can help to reduce. And again, attacking weeds in patches that grow in patches is a smart thing, because weed evolution happens in patches. There are areas of the field that are, let's say, more hospitable to a particular weed, and they will capitalize on those areas and tend to dominate there and then spread from there through the field with tillage, or if there's no tillage, with wind dispersal or with animals or whatever. So attacking patches is a very good strategy, and it makes sense in small areas where we have small fields, like let's say where I live in Germany, where I think the average farm size is something like 60 hectares, and I've been in some fields in Mato Grosso where one field is 3,000 hectares, and so if you have a small area, treating whole fields as one makes sense. But in Mato Grosso, maybe you have to start thinking of treating patches and working on slowing weed resistance evolution that way. Now, if the rooting habit is shallow, maybe a shallow cultivator can work. And maybe again, in big areas like Mato Grosso or Goiás, maybe you use a cultivator just on the worst parts of the field. Now, if the growth habit is tall, you can maybe collect the seed heads before harvest, if the patches are small enough. If the seed number is high, in Australia, they've had wonderful success with the post-harvest weed seed destruction for the lolium. That is a major problem there. If the dispersal mechanism is through wind, well, sometimes putting up field borders with trees or some higher growth plants will help to slow the dispersal of seeds by wind. If it germinates from the surface, crop mulch is a good way. I mean, there's some interesting work being done with stubble management and mulchers that add a layer of the previous crop that used to be burned, but in many areas it's outlawed. But it's a great way to kind of shade the weeds and provide some suppression of weed germination. And if it prefers wet habitats, like in patches in the field, well, that helps to control them that way. So if we look at okay, well, I'm going the wrong way. If we look at what else we could do to help farmers manage resistance, we got to look at the field history and get them to add a few more non-chemical practices to chemical control. So I know plowing is a nasty word in many areas, but it does bury seeds and control weeds. And again, consider for big area farms, maybe just plowing patches. That might help. But in England, for example, with blackgrass or Albicurus myasoroides, they found that if they plowed every year, what they would do is they would bury the problem, put it into that refrigerator of soil, so the lower temperatures, and it would sit there dormant. And then the next year it would be plowed and come back up again and germinate. So it would go in 2-year cycles, but every year if they would do it, it would cause some major issues. But if they reduced it to about 1 in every 3 years, and it depends on the field, on the density of the weed problem, that worked much better. So crop rotation is really one of the best aids in diversifying your herbicide options, providing the ability to have, if it's appropriate to the situation in the region, to give a crop in the counter season, which kind of attacks the biology of the target weed, and that works really well. Planting a crop, they found also in, let's say, the UK, that if they delayed it with a false seed bed, meaning that they used their pre-plant burn down later, then they could really increase the level of pre-plant weed control that reduced the in-season population of weeds. And this can work also for summer crops, but you would have to delay a little bit. But farmers I know are nervous about delaying it for reasons of maximizing the yield potential. But what the weeds are taking away sometimes is actually more than the additional gain from planting earlier and having a longer season. So herbicide program, it's surprising how few farmers really do, let's say, the optimal to improve the herbicide efficacy in terms of formulation and optimal conditions, spray volume, pressure, nozzles, wind additives. We did a survey of farmers visiting our integrated weed management or IWM-Platforms, their demonstration trials. And in Germany, it was only 50%. And in France, it was only 70%. For me, it was like the opposite. It was 30% that we didn't reach in France and 50% that we didn't reach in Germany, that still didn't worry about optimizing the herbicides, throwing money away. But I guess, sometimes it's really difficult to change farmers' habits. Field borders, again, sometimes they can be a source for reinvasion. Farm machinery, you have to make sure that they're weed seed free, but sometimes for really small seeded weeds, like for amaranth species, it's difficult. And then resistance on the farm in the local area or region. What it really helps is when farmers work together as a community, and many programs have shown that if the farmers work together, there's more peer pressure, there's more information, and they trust each other more than they trust outsiders coming in and telling them what to do. And that works really wonders in terms of trying to manage a resistance issue in a local area. So what are some of the factors that influence herbicide resistance evolution? Okay, you can divide them up into chemical practices and agronomic practices. And these are results from a multi-year study with Alpicurus myasoroides in southwestern Germany. It was a guy doing his PhD in our labs, Johannes Hermann, who went and interviewed farmers and gained their trust and got them to give him the field history, sometimes up to 10 years or more. And we had a minimum of 6 years of field history for 92 fields in 3 different local regions in that area. And these were then followed, and we looked at the resistance profile of each of the fields and looked at the practices and made some correlations. So what we did was divided up these practices and the number of Alpicurus specific herbicide applications, if they were greater than 6 for a particular, from all modes of action, the number of unique modes of action applied to the crops, if it was less than 4, the number of group 2 or ALS herbicide applications was greater than 3. And remember, this area already had major resistance to ACCase herbicides, and then ALS had been used for about 10 years to 12 years, and we started seeing some resistance issues, which is why we started this study. When we looked at these, we found that the number of Alpicurus specific herbicide applications greater than 6 led to a 30% increase in resistance or risk of having a field considered to be resistant. the number of unique modes of action didn't really make much difference. The number of group 2 and B ALS herbicide applications, of course, greater than or equal to 3 made a huge difference. It increased the risk over 3-fold. Now, the agronomic practices, the number of winter cereals in rotation greater than or equal to 3, number of spring crops in the rotation less than or equal to 1, number of different crops in the rotation less than or equal to 4, number of delayed seedings less than or equal to 1, and the number of inversion tillage operations less than or equal to 4. So the number of winter cereals in the rotation had an 8-fold increase in resistance if it was greater than or equal to 3. The number of spring crops in the rotation, if it was 1 or less, it had a 5-fold greater chance of being resistant. The number of different crops in the rotation, if it was less than 4, and this is over a 6-year period, if it was less than or equal to 4, it was 7 times greater. The number of delayed seedings, if it was less than or equal to 1, you had a 3-fold greater increase, which is about equal to having 3 or more group 2 herbicide applications. And the number of tillage inversion operations equal to or less than 4 is about the same. So the point is that the agronomic practices sometimes make a bigger difference than you think, and it sometimes can even be bigger than the chemical issues or factors that go into selection for resistance. So they work hand in hand. So I should have showed this slide first so you understand a little bit. This is Allopacuris mysoides in germination, and you can see here that that in autumn 80% germinate, and you have some in the winter, some in the spring, and very little bit in the summer. And then the usual practice was that you had planting and harvest. You did a full tillage, and you did a post-emergent herbicide in the spring, and that was it. Well, more and more people, as they went into the no-till farming, they replaced that full tillage with a pre-plant burn down, and then they had a post-emergent spring treatment. So this pre-plant burn down was mainly glyphosate. Of course, in some areas you had paraquat, but then that was banned for Europe. And so then what they found out was that with time, they had issues with the greater and greater germination coming even earlier. People were planting earlier and earlier as possible. And so what they had to do was they went to a shallow tillage to stimulate the germination of the blackgrass. They delayed the pre-plant burn down and the planting, and then that led to, and then they included a pre-emergent herbicide in the program, and then they went to the post-emergent spring because that's what they had to do to control the blackgrass as it was getting more and more resistance to ALS. So they were forced to go to more integrated weed management systems to manage the resistance. And our demo platform in France was run on large plot sizes between 0.5 to 1 hectare per plot. And what we had again was Allopacuris, and in the population density in the beginning was low to medium. The ACCase resistance, of course, had already been resistant, just like in Germany, and the ALS resistance was low. And at the end of a 6-year period, in the standard program, they had high resistance to, or high density of blackgrass, high ACCase resistance. Of course, that wouldn't have changed very much because once you get resistance in the field, it tends to stay. And the ALS resistance then was high. And at the end of the integrated program, you had low densities and no ALS resistance. Of course, no change in the ACCase resistance as you would expect. So what did they do in the standard program, which was, again, as I described? And then in the integrated program, they had a false seed bed, delayed seeding, an inversion plow twice, On fall seed bed, delayed seeding was every year that they had winter wheat. Spring crop, they had one, which was a corn, and one winter oilseed rape instead of the cereal. So that really worked. Now, what did it cost? The standard program cost 60 euros per hectare. The integrated crop program cost 195 per hectare. Now, try to sell that to a farmer. It's 135 euro per hectare more. I mean, almost 3 times more expensive. But what farmers don't see is that weeds rob yield silently. And they do a very good job of it, because when you look at the net return over those 6 years, the farmer that ran the integrated program, despite the increased cost, actually got 404 euros per hectare return higher than in the standard program. And so if you put it another way, it gave a return on an investment of 300%, or from another viewpoint, it costs a farmer 404 euro per hectare per year to run the standard program. And so we think that these demo platforms are really an effective way to show farmers. And in fact, in surveys that have taken place afterwards, they respond to these programs much higher than any external influence, including internet or advisors, to changing practices. And it's not the adoption rate is still pretty low, but it's the highest thing and the best thing we've got. So new digital weed control tools in the future applied at key intervention points in the weed biological life cycle are coming. And what they can do is, help with weed scouting and identification with drones, robots, kits, software, precision herbicide application and weed control with tractor-mounted devices or drones or robots and software, and then others with other applications that we haven't, and services that we haven't even thought of. So they're coming, and people are working on them feverishly, and there are a lot of startups doing things with drones and other things, and we will get some help in the future. We've started to discover more herbicides, but we need to protect them. So going forward in the near future, the focus is on the money and the weed seed bank. And that, I think, will help convince farmers, because it pays off to start clean and to manage the weed seed bank with an integrated program. So in summary, weed resistance is a growing problem, and it will continue to grow. And we must understand that target weed biology is an important thing to understand in order to effectively manage resistant weed populations. The level of herbicide efficacy does affect seed bank dynamics, as I've shown with the theoretical model. The agronomic practices affect resistance evolution, as I've shown with the increase in risk in that German study. Showing the farmers the consequences of resistance is the most effective way to get them to adopt the IWM, but also about the money. And integrated solutions are the way forward. That's actually the way it should be written. Well, we're going to have new herbicides, and more new herbicides are coming, and new tools, but they need to be protected from the time they enter the market. Even the non-chemical ones. If you use the same one over and over, you can develop resistance to non-chemical weed control. For example, the oldest way to do weed control that humans know is to pick them by hand. And how can you develop resistance to that? Well, in China, an Echinocloa cruscale population, or barnyard grass population, has developed resistance by mimicking the phenotype of the rice plant in its early stages. Of course, later on, when it starts sprouting the seed heads, then, I didn't pick that. And so there are ways to overcome any practice, even non-chemical ones, by weeds, and we have to guard against it. We have to keep switching up and diversifying our tactics, and not going to one thing and just staying with it, even though that's the easiest thing to do. So with that, I thank you very much. Muito obrigado. And so I would be very happy to discuss or answer any questions that you might have. So I guess I should open up the chat.
Thank you so much, Dr. Harry, for excellent presentation. You'll be able to see the question. We have some questions from the audience in the Q&A sections. Probably best is if you can get on them.
I don't see any questions yet. Oh, Q&A. Ah, there we go. I was
Q&A.
There we go. Answer live. Okay, several strategies to resistant management have many issues related to weather, winter, seasonal crop rotational, water availability, and accordingly, and considering the conditions of tropical countries from your experience, do you consider that resistance management in those countries is more complex, or even the evolution of resistance is going at faster rates? Well, we've always said, since you have like 2 seasons in Brazil, 2 crop cycles, that you're going to get faster resistance evolution. But when we compare the rates, actually, as the rate that I showed you in that graph in the beginning with the grasses and broadleaf evolution, when we look at the long-term rates in the United States and compare them, they're actually faster in the United States. And so the evidence that we have, okay, this isn't, you got to understand that the database that we're using is just unique cases. And so the complexity of the resistance that's developing is not going at hypersonic speed in the tropical areas with these things. What these changes in the weather and conditions and everything do is that they change the level of efficacy of herbicides every year. So every year you cannot expect 95% plus weed control. Some years you're going to have less. And when you do, you're going to have more weed seeds, and you're fighting that for a longer time. I mean, there's a saying, I forgot what the saying is, 1 year's weeding is 7 years, no, 1 year's seeding is 7 years weeding. So in other words, if you have an escape year, you're fighting it for 7 years until you kind of can get it under control. So the next one, in Argentina, the weeded system optical detection sensor allows farmers to use really high doses, sometimes 5 to 10x over annual on a Leucine indica with clethodim or imazapyr over sorghum halopensi. What could happen in those scenarios? Well, first of all, it might not be a label application, and so we have the labels are written so far with per area applied rates. Now, what it'd be nice is if we could get some sort of leeway to do that a little bit, maybe not 5 or 10x higher. What it does is, okay, it might work, but you remember, you're not applying it to a totally sensitive population anymore. And these populations have been groomed and have increased the level of resistance, particularly some of the populations that have metabolic resistance. So when you hit them with really high doses, you're still exerting selection pressure, and it's not a fail-safe solution by any means. You still need to get into integrated weed management. First of all, you gotta follow the label recommendations, and secondly, if we can convince regulators that some form of this higher dose, small area could be figured over the entire field within limits, I think that might be a good idea, but that's my personal opinion. What's the role of herbicide-resistant crops in the management of herbicide-resistant weeds, in your opinion, now and in the future? Is there interest for Bayer and other major ag companies in expanding HR crops to minor crops beyond soybean, corn, cotton, and other chemistries beyond Group 4927? Yeah, I would say that, it takes a lot of money and a lot of time. It takes sometimes, on average, longer to register a new HD crop than it does to register a new herbicide that you've discovered and go through the full package. And it's just as expensive. So the minor crops, it's going to be a tough call. And I don't know, there's no IR4 type of program that I can see so far that could help with some of the costs. But it's an interesting question. And I'm not in the seeds part. I do have colleagues, of course, that could answer it. And if you contact me afterwards, if you would like, I can ask some of my colleagues to provide a better answer than I can. At present, what's the role of monitoring with the advancement of resistant cases? Present in the future, gene stacking will be used to provide materials resistant to multiple herbicides. Could this make weed management more difficult in the future? Well, one thing you've always got to do is you got to watch out for volunteers, okay? Especially like in Brazil, it's a major problem. So you always have to have a fail-safe control method. The idea is that you would switch modes of action on these crops that you might not ordinarily use. So the principle of it is it's supposed to help you with your resistance management. Let's see, the protection of existing molecules is mandatory. However, the development of new molecules has been slow. Yeah, where do you think discovery is headed? As I mentioned before, I think I tried to answer that a little bit. It's starting to increase a little bit. Part of the problem has been that the industry has consolidated so much, and we've lost chemists and biologists that are working in discovery with each consolidation, so that the intellectual capacity of what we have now versus 30 years ago is probably in the order of 10 to 20% of what we had. But I see that it's coming back up again. There's companies that have basically really dialed down their herbicide discovery research, but started back up again. And I see that we'll have more discoveries, but again, the barriers to registration keep getting higher, higher, and higher. And when we start a registration program or a discovery program, we find something that we would like to register. We don't know what the rules are that's going to be governed by the time we submit the registration until the end of the process. So the game is changing. The rules are changing as we register, and that makes it a little bit difficult to plan. But it's still, valuable to bring these herbicides, new herbicides to the market. So I anticipate there will be more coming. Okay. Triggering germination with shallow cultivation is likely associated with delayed crop seeding. Could this reduce crop yield and reduce return? When you compare it to what the yield loss is from the increased weed competition, I think you're actually getting a boost, and that's what farmers are finding. What's your opinion on weed emergence prediction models in IWM? Are they applicable, and have you worked with a successful example? I know that there have been out there, but I have not personally done that. And I'll answer one more question, which is the last one. There's no label recommendation for weed systems in Argentina and any company as in Australia. Farmers do that, and the chemical companies are not attending to the issue. I don't understand for weeded systems. What do you, can you help me out?
I think it's for from what I understood, is from the system that spray, spot spray. The weeded,
the spot spray, the first, yeah, okay. Yeah. No, you better believe it. Companies are paying attention, absolutely. We're looking at precision applications and doing all kinds of things. Every company's looking at it. So, as of right now, like I said, people are working on things. Big companies are looking at them. Small companies are looking at it. So there are developments cooking, but there's very little coming out. It's going to come, and it's going to come usually like weed resistance. It's going to start out slow, and then you're going to get an exponential rise.
Fantastic. Okay. We would thank you, Dr. Harry Strek, for your excellent presentation. As we could see, the topic is very interesting for everyone. We had a lot of questions, so And it's very clear that we have, as agronomists at Weed Science, we have to move forward and make this knowledge to get to the farms. Integrating is the way to deal with resistance, and we manage we have no clue about it, no question about it.
And
So
remember, the hardest part of the job is to convince farmers to do it before they have a problem. It doesn't seem to work very well.
yes, of course, the simplest thing is always the first option, and we have to have a change on mindset. That's something that's not easy to do for sure.
Yep.
We
Okay.
really appreciate your time and to stay with us this late. So thank you so much. And just the last note, to invite people to be with us next week. Same time, we will have our last webinar. Okay. Thank you so much.
Okay, thank you.
Stay safe, everyone, and we hope to see you next week. Bye-bye. Boa noite.
Boa noite.